Hello and welcome to example 10a. In this example, we need to find the volume of the solid of revolution obtained by rotating about the x-axis through 4 right angles, the region bounded by the curve y equals to x squared, and the x-axis between x equals to 1 and x equals to 2. Now, it is important that you understand what we mean by 4 right angles. That is 360 degrees. That means we revolve the region through one whole complete circular revolution. Another important question is where the region is. In this question, we say that the region is bounded by the curve y equals to x squared, which is what we have shown in the diagram here, and the x-axis between x equals to 1 and x equals to 2. So how am I going to locate this region? I understand that x equals to 1 is a vertical line like this at x equals to 1, and x equals to 2 will be another vertical line. 2 is right. So when we say the region bounded by the curve y equals to x-axis, y equals to x squared, and the x-axis between x equals to 1 and x equals to 2, do you see the red highlighted part of the x-axis that I am highlighting now? So we are talking about the region bounded by this curve. Now I'm outlining in red here, and the x-axis between x equals to 1 and x equals to 2. So we are talking about this region that I am shading now. I will proceed next to show you how the solid generated by revolving this shaded area looks like. So in this diagram, we have the region shown. When I revolve the required shaded region about the x-axis, this is what we get. Let me change the angle of view for you. Now what do you see? You can see the revolution here from the side. We see a circular cross-sectional area, of course. And if you look from this angle, you can see something that is part of a trumpet. So I need you to remember that the volume is obtained when we get the sum of all these circular discs that we use to approximate the volume found. So let's get back to the to see the question. Now, when we need to find the volume generated, recall that in the animation that we get the total volume by summing up the volume of all these circular discs. If I draw one of them, we have seen before that the radius of each circular disc is given by y, and we know that the area of the circular disc is pi y square with the thickness as delta x, which translates to dx and integrated from 1 to 2. So remember, this is what we have derived before, and this is the formula that we will use here. In general, when you revolve about x-axis, we should be using the formula that ends with dx, and with the limits of the integration having the values of x equals to 1 and x equals to 2 here. So when we apply this formula, substituting in y equals to x squared, we will obtain this. after we have substituted y as x squared. And when we evaluate this integral, we will end up with 31/5 pi unit cube. Thank you for watching this video.